Hello. In video number 7, we studied about the series combination of cells. Today, we are going to see about the parallel combination of cells. In parallel combination of cells, cells are connected parallelly. Parallel means number of cells are connected in such a way the positive terminal of each cell is commonly taken and negative terminal of the each cell is commonly taken as another terminal. So let us consider two cells, that is cell E1 and E2 are the two cells, positive, negative, positive, negative. Positive is commonly connected and taken as a terminal, one terminal, and negatives are commonly connected taken as the another terminal. That is V1 and V2 are the two terminal. So the voltage at V1 is VB1 and potential difference at V2 is VB2. Okay. Such combination is for the parallel combination of cells. In parallel combination of cells, once we set the voltage, once we set the EMF of the combination, we can't increase while increasing the number of cells. So this is the disadvantage. Okay. If number of cells are connected in parallel and we decided a certain, we built a certain EMF due to this combination. Meanwhile, any cell gets damaged, the circuit will not be break. Or you can say the circuit will not be break. That's why it is the advantage of the parallel combination. Now, what is the net equivalent EMF? We have to find out here. Equivalent EMF and equivalent internal resistance of these cells. That is RN or R equivalent. We have to find out here. These cells are in parallel combination. So, whatever the current flowing through each cell, that is, current is always flows from positive to negative, I1. The current due to the cell E1 is I1, the current due to the cell E2 is I2. Both currents are added here. So I is equal to net current due to this combination, I is equal to I1 plus I2. Now what is I1? I1 is the current due to the cell E1. That is given as, we already studied about that, E1 minus V upon R1. If external terminal potential difference means external resistance, voltage across external resistance is the terminal potential difference. Okay, V we have to, it is the equation for I1, and equation for I2 is E2 minus V upon R2. Add these two equations, that is I is equal to E1 minus V upon R1 plus E2 minus V upon R2. Now I is equal to, what you will get here? I is equal to E1 upon R1 minus V upon R1 plus E2 upon R2 minus V upon R2. By simplifying this, I will get, that is, I is equal to what you will get here, P common if you talk, means E1 upon R1 plus E2 upon R2 minus V into 1 upon R1 plus 1 upon R2. That R is equal to E1 R2 plus E2 R2 divided by R1 R2 minus V into R2 minus R2 plus R1 means R1 plus R2 divided by R1 R2. Now V is equal to what? So V is equal to, if you plot this side, what you will get here? P is equal to that R plus V into R1 plus R2 upon R1 R2 is equal to E1 R2 R2 upon R1 R2. So V is equal to what here? E1 R2 plus E2 R2 upon R1 R2 minus R, that is V into R1 plus R2 upon R1 R2. Therefore V is equal to you will get, by giving this side you will get V is equal to reciprocal, means we have to multiply this here R1 R2 upon R1 plus R2, right? And here minus R into R1 R2 upon R1 plus R2, which means that you will get V is equal to E1 R2 plus E2 R2 upon R1 R2 minus R into R1 R2 upon R1 plus R2. We have an equation, that is EMF of the circuit. In that we already studied that V is equal to E minus I, you can write that E minus E equivalent, that is E means E equivalent, minus R into internal resistance, that is internal resistance. So here internal resistance R equivalent, internal resistance is nothing but R1. To equate these two equations, while equating these two equations, this stands for R equivalent and this stands for E equivalent. So we can say that E equivalent is equal to E1 R2 plus E2 R2 divided by R1 R2, and R equivalent is equal to what? R1 R2 upon R1 plus R2. This is the equation. So the same, we have the R equivalent for only two cells. If n number of cells are there, means what you can write here? R equivalent is equal to, what is that? N for n number of cells, that is reciprocal of equivalent of the resistance, that is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus dash 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 plus 1 upon Rn, is it? And here we have an equation, net current flowing through the circuit is nothing but E equivalent, or if the parallel combination is considered as a single battery, then the net current is E equivalent into R divided by R equivalent. E equivalent divided by R equivalent, that is equal to E1 upon R1 plus E1 upon E2 upon R2 plus dash 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 plus E upon Rn. These are the equations we get for the parallel combination of the cells. Now next we are going to see about the types of the cells. What are the types of the cells? There may be two types of the cells are there. One is parallel combination, also one is primary cells, and second one is secondary cells. Two types of the cells. First one is primary cell. Primary cells, types. Okay, types of cells. First one is primary cells and second one is secondary cells. Okay. Secondary cells. The name itself says primary cells. Primary cells means these cells can be used only once. These cells cannot be reused. Means the cells, once you use the cells and once the cell gets discharged, the cell cannot be charged again and again. For example, your dry cells, whatever you are using, the dry cell for the battery, torch, or many dry cells, you know about that. Okay, these dry cells are the primary cells, and these the value of this cell is very low. These are easy to connect anywhere, easy to use. Okay, but the they cannot use for the heavy load. These cells cannot be used for the heavy load. The secondary cells are those cells which can be reused again and again. For example, chemical cells, all the chemical cells for which we are using for the car, vehicles, is it? These are the, we can reuse, we can charge again and again. Such cells are charged again and again. They, even though the value, cost of these cells is more than the primary cell. These cells can be used for heavy load. These cells can be used for heavy load. Okay. And fuel battery. Example for the secondary cell. Many more example. Lead acid cells, then solar cells, and chemical cells, and number of different chemical cells. And another one is fuel cells. In fuel cell, hydrogen is used as a fuel. Okay. These are the types of the cells. Okay. Thank you. Here the lesson will complete, and you have to solve the exercise question. I will send that reduced portion along with this video, and you have to note out that and that much portion you have to study. I taught every portion from this lesson because it is useful for the next year. So whatever the reduced portion that you delete, that you reduce, and remaining portion you have to cover from this notes only. And the exercise question you have to solve yourself. If any difficulty